Let us have an understanding on Lambda architecture and Spark stack. In any big data project or in any big data ecosystem, we will be having enormous amount of storage and enormous amount of compute capacity, and that will be provided by either a private cloud or a public cloud. So n number of machines will get together to provide massive storage and massive storage capacity. And I might have huge amount of historical data where I will be bringing in through a batch process, or already I might be having it in my storage. And there will be a continuously generating data from sensors or from third-party system or from my own servers or applications or any apps. The data, it will keep on getting generated, and I will be storing that specific data as well. But to leverage or to add value to the customer, we will be trying to predict few of the values to the customers, where I can mine the existing historical data and apply a machine learning algorithm to generate a model. Model is nothing but extracting the pattern existing within the data. Very simple example. What is the pattern for any false claim that is getting submitted to the insurance organization? Or another example, what is the pattern the sensor is going to emit before it's going to fail? So if I can extract that specific pattern, and if I can store that as a function or a model, I can inject the streaming data that is coming from the sensor, and I can predict, is there any chance of that particular sensor about to fail, or that particular application being a false claim or not. It will help me to predict well in advance before the incident about to happen. And I can feed that data either into the dashboard or send across a message to the customer. In this particular architecture or in the data flow pipeline, we see three layers. One is the batch layer, where I'll be processing enormous amount of data which is stored in the storage capacity, and speed layer, where I will be getting huge amount of data with very high velocity, and I may want to compare it with the existing model or the model generated out of the batch process. And I'll be having a servicing layer where I'll be providing the information to the customer what is about to happen or what may happen. I may want to project, or what is happening now currently in the system, I may want to project that as a dashboard or send across a message. All this can be achieved with various components or tools available within the Hadoop ecosystem stack. And Spark also gives a number of components where multiple stack requirements can be satisfied within the Spark. Let's have an understanding on the Spark stack, where Spark works in a distributed system. So we need a resource manager to manage a number of machines resources. Either it could be a Mesos or Yarn, and Spark comes with its own resource manager. So the management of the resources will be handled by the resource manager. And storage can be satisfied by either the HDFS, that is Hadoop Distributed File System, or Tachyon, which provides memory-centric distributed storage, where the data will be stored in memory and the retrieval will be very fast and quick. And parallel to Spark, we have other components like Hadoop MapReduce, Kafka, Storm, Mahout, and there are n number of frameworks and tools to handle various requirements. And Spark comes as a stack where n number of tools built in within Spark. Whenever we are using Spark, we can enjoy the benefit of using various languages. Either I can use Python or Scala or Java. Spark exposes all the three API where I can do the programming in any of these three languages. And Spark has the base component called Spark Core, which facilitates us to do the in-memory distributed computing. On top of it, we have specialized packages like Spark Streaming to handle continuous generated data, and GraphX, which works on graph theory, where I can work on interconnected data. And I have a package called MLlib, which will facilitate us to run various type of machine learning algorithm on any data. And we have Spark SQL, which will help us to do the analysis or work on a structured data. Like this, we have a number of other packages as well. And Spark also have a package where it works with R language to interact with the data. And how these Spark components or the packages going to satisfy the Lambda architecture, we can have a quick look. Any data, whether it is a static data source or a dynamic or streaming data source, that can be consumed by Spark Streaming or by Spark Core. And Spark SQL will be used to do the structured data analysis on the either on the streaming data or on the static data. And MLlib will get involved to identify the pattern, to precisely say, to extract the model out of huge amount of data. And Spark SQL can interact with the Spark Streaming, or it can read the data from a static data source or a streaming data source, and it can generate the result, and the result could be stored in any persistent storage. So in a summary, Spark provides various packages to satisfy various layers of the Lambda architecture, and that's why Spark is called Unified Analytical Engine, and which does distributed in-memory computing.